Hi there, welcome back to Haguin School. We'll be doing a past year walkthrough of Cambridge International AS and A-Level Computer Science for Paper 1 Theory Fundamentals. We'll be doing the 9618/12 variant for the May-June 2025 series. For this walkthrough, you need a question paper as well as the mark scheme. The table has 6 statements about a von Neumann model for a computer system. 3 of the statements are incorrect. Complete the table by writing the 3 incorrect statement numbers and the corrected statements here. So for these 6 statements here, there are 3 incorrect statements here. And let's look at the first incorrect statement. It will be statement number 1 here. So what is the mistake here? It's going to be the program counter PC stores the address of the next instruction to be fetched from memory. So it stores address, not instruction here. And the next one will be this statement number 3 here. So for number 3 here, the control unit CU sends signal to other components on the control bus. So here it said that it's data bus here, which is wrong here. And the last incorrect statement will be statement number 4 here. The memory data register MDR holds data read from the memory address in the MAR. So it holds data, not transfer data here. So this is how you can get 3 full marks for this question here. As long as you know what each component does, this is just a definition question. Registers, they are used in the fetch execute FE cycle, include the PC, MAR, MDR, and the ACC. Identify one other register and describe its role in the fetch execute cycle. So what register can we use here? We can just put current instruction register. So what does CIR do here? So for the name itself, we know that to store the instruction to be decoded. So this is how we could score 2 marks for this question here. For C, explain how an interrupt from an input device will be detected and handled in the FE cycle. So this is the typical interrupt question here. If you know how interrupt works, this is just an easy question here. So first of all, we can write at the start or end of FE cycle, the interrupt register is checked. And next, if the priority of the interrupt is higher than the current process, the contents of the registers are stored on the stack. So you can just imagine this, that as you are doing your homework or past paper, your mom came to your room and asked for your help. So you will have to set your work aside first and help her to settle her request first. And then next, the relevant interrupt service routine ISR is called to process the interrupt. And finally, when ISR finishes, it will check for higher priority interrupts, and if no more interrupts of higher priority, the register contents are restored and the next FE cycle continues. Convert the denary integer 558 into 12-bit binary and hexadecimal. For this type of question, normally what I would do is that I would just write something on the right here, which is 1 all the way to 2048, since it's a 12-bit binary here. And next, I will look at how I can derive 558 using all these numbers here. So 558 is equal to 512 plus 32 plus 8 plus 4 plus 2. And then I can just put 1 below all these numbers here. It will be this number here. So 1 below 2 here. And then 1 below 4 here, and then 1 below 8 here, and then 1 below 32 here, and then 1 below 512 here. And next, I will just replace all the empty space here with 0 here, resulting in this final solution here, which is 001000101110 here. And for hexadecimal, it's quite straightforward. We can split them into chunks of 4 here. So 0010 is equal to 2 here, and then 0010 is equal to 2 here. And then 1110 is equal to 14 here, which is equal to E here. For BI, convert the 2's complement binary integer 11100010 into denary here. So for this one here, we can just write 11100010 is equal to 2 plus 32 plus 64 minus 128 here, since this is a 2's complement. Therefore, the most significant bit here is going to be negative value here. And then we can just sum them all together, resulting in negative 30 here. Write the smallest and the largest 2's complement binary integers that can be represented in 8 bits. So the smallest will be 10000000. So this is going to be negative 128 here, which is the most negative number here. And next, the largest will be 01111111, which is going to be 127 here. And also, if you are taking my fast track program, you can see that for each question, I will list down the chapter and their respective topic name. You may go through the topic again in my program if you find that you are not 100% sure on certain solution at this point of time. And next, Give one application where binary coded decimal BCD is used and justify its use. So first of all, the application will be electronic displays here, and the justification will be conversion between denary and BCD is straightforward. So if you look at this answer here, you might not understand what it means here, but no problem here. Let me just show you one example here. For example, I have 15 is equal to 001, 0101 here. So this is the binary representation for 15 here. And let's say for this electronic display here, we want to represent 150 here. For this BCD here, it's going to be very simple here, which you can just add 4 zeros at the end here, resulting in 001, 0101, 000. So this is what it means by conversion between denary and BCD is straightforward. A computer program uses a digital camera to read the words on an item. The program can read the words that are written on the item, translate the words to a chosen language, and then output the words as audio. For example, when used in a supermarket, the program can output the words written on the labels on products. The program uses artificial intelligence AI. Explain how AI is used in the computer program described. This is a 4 marks question here. So for this kind of question, normally how we can get 4 marks here is pretty simple here. We can just write the feature for 1 mark here, and then the description for another mark here. And now let's look at the feature for this question here. So for the feature, we have 3 features here. First will be read the words. So this is the first feature. And next, translate the words will be the second feature. And the third feature is going to be output the words here. So based on these 3 features, we can just write how we can do this feature 1, feature 2, feature 3, and then write the description to score full marks for this question here. So first of all, for read the words, we can write uses image recognition. So we will use image recognition to read the words. And then what is the description for this function here? We can just write to analyze a photograph to identify the location of characters within an image here. Because when we scan an item here, it might not be full of words. So maybe certain portion, it has some words here. So we will need to use image recognition to find the words and the character within this image here. And next will be translating the words here. So for translation, we can just use natural language here. And the function or the description will be to combine the characters into words and translate the words to users' chosen language. So once we write down one feature, the description, one feature, one description, we could score 4 full marks here. But for demo's sake, let me just write down the last feature as well here. So it will be users text to speech here. So we'll use this function here to output the words here. And what it does is that it will generate the audio waveforms corresponding to the words here. So this is how we can score 4 marks for this question A. And next, state 2 social benefits of the use of AI in the computer program described. So for the social benefit, we can just write, it can help people with visual impairment to identify which products to purchase. So let's say certain people, they cannot see properly. We can just use audio to tell them, hey, what this product is all about. And next will be, it can help people who cannot understand the language. So this is very helpful when we are in foreign country. For example, let's say you only know how to speak English and right now you are in Japan and all the items are in Japanese here. So this software here is going to be very useful here. The computer program is released under a commercial software license. Describe the features of a commercial software license. When it comes to commercial software license, you can think of software like Microsoft Word here, Microsoft PowerPoint, or Microsoft Excel here. Since this is a 3-mark question, we can just write 3 features here. So the first feature will be the program is usually sold for a fee here. So for example, for all this Microsoft software here, you have to pay to subscribe or use the software here. And next will be users have no access to source code, and definitely you got no access to the software or the code behind all this software here. And next, there are limitations on the use of the software. For example, number of times it can be installed. So for example, for Microsoft 365 subscription, normally we have different tiers whereby it allows different number of persons to use at any point of time. Explain the reasons why an open source software license might not be appropriate for the computer program described. So this is a 3 marks question here. So first of all, we can write the source code will be accessible, therefore it could be changed. So this is the main feature of an open source software license. But it's not something that Microsoft wants, since it will affect the overall user experience if you go and edit their code. and then this might lead to the program outputting an incorrect response, which might have serious consequences. So if you are using all these commercial software to do your important project, this is not recommended. Write the logic expressions for the following logic circuit. For this type of question, normally, I will label the intermediate state first. So first of all, let's look at this here. So we have R and S here. So this is going to be an intermediate state here. And the resulting output is going to be A is equal to R NOR S here. So R input and then S input feeding into this NOR gate here. And then next, let's look at this X here. So for this X here, we have this A going into X here, as well as this T going to X here. Therefore, the final answer will be X is equal to R NOR S bracket XOR T here. So this is the answer for this X here. And then for the bottom here, same thing again, let's look at the intermediate state first. So we have T and U here, resulting in B is equal to T and U. And then for Y is going to be this B feeding in, and then this U feeding in into this Y here. Therefore, the final solution for Y is going to be T and U or U here. Complete the truth table for the logic expression. X is equal to not A and B XOR C here. Same thing again, we will label the intermediate state. So the first intermediate state that we see here is going to be B XOR C. Let me just label this as D as the intermediate state first. And next we have this E here, which is this red border here. So A and B XOR C is going to be the E intermediate state first. And then I will label these two as two separate columns in this table here. So we have D column and then E column here. And now let's start from D here. So for D is going to be B XOR C here. So 0 XOR 0 is going to be 0 here. And then I will fill in the remaining rows here, resulting in this 1 1 0 0 1 1 0 here. So the output is going to be 1 when either of the input is 1 here. And then for E, it's going to be A and D here. So A input and then D input here. And let's look at this. A and D. So 0 and 0 is going to be 0 here. And then same thing again, I will fill in the remaining rows here, resulting in this 0 0 0 0 1 1 0 here. And finally, it's going to be this NOT output here. So I will be NOTing the whole E here. So it's going to be the opposite of the input of E here. So 0 is equal to 1, 0, and then 1, 0, and then 1, and then 0, and then 1, 0, and then 1, and then 1, and then 0, and then 1, and then 0, and then 0, and then 1 here. For this question, it might look a bit confusing at first, but once you follow my method here, it's actually relatively straightforward. If you find that you have learned something new from the past year walkthrough so far, definitely give this video a thumbs up and share to your friends who will benefit from this video. And if you're looking for the fastest and most direct way to score top grade for your upcoming Paper 1 or Paper 2 exam, check out my fast track program at www.haguin.school. Inside the program, I will show you exactly what to study, what to ignore, and the fastest way to master every topic so you don't waste time learning things that won't even show up in the exam. And now, let's go to question 5. An online game has a database that stores data about users and the characters each user creates in the game. Each user can create multiple characters and purchase multiple items for each character. The normalized database has the following design. So we have this user table, character table, item table, and the character underscore item table. Explain the purpose of the table character underscore item in the database. So what is the function of this particular table here? It's going to be used to remove the many-to-many relationship between character and item tables. You can just imagine that we need this intermediate table here to make sure that the database is fully normalized. And next, underline the attribute or attributes that form the primary key in each of the tables. So for user, it's going to be username. For character, it's going to be character ID. For item, it's going to be item name. For character underscore item, it's going to be character ID here. So for tables here, in general for primary key, they tend to put ID for the primary key itself here. So when it comes to exam, if you look at ID, normally it's the primary key for the table itself. For C, a database management system, DBMS, provides data security. Identify two methods the DBMS can use to protect the data in the table user from unauthorized access. Explain how each method protects the data. So the first method is going to be the most straightforward method, which is going to be a password for the database. And the explanation is going to be prevents users without the password from accessing the data. And then method 2, we can write access rights, meaning that appropriate permissions for the table user are needed to read or edit the data. So we can use password or access right to protect the data here. And next, the DBMS also supports data integrity. Give two ways that a DBMS can support data integrity. So we want to make sure that all the data is consistent here. First of all, we can write enforce referential integrity, which means data stored in the tables must obey all of the relationships that exist. And the second method, we can follow the previous slide here, which is ensuring the database is normalized. Write a structured query language SQL script to count the number of items purchased by the user with the username cat123. So I've copied the table design from part B into this page here. And now let's do some visualization first. So first of all, we have this user called cat123 here. And then in the game itself, she created a character here, which is this character here. And then in this character here, she bought multiple items here. So this is the visualization based on this question here. And then next, let's look at what are the tables involved. So first of all, we need to count the number of items. So look at this, from which table we can get number of items. It's going to be this character underscore item here. So we can get a number from this table here. And next, we have to filter by the username. So we can use either user or character table here, but definitely we need to join the table. So the table that we choose is going to be character table here. So we will be using this character table here. So we'll be using these two tables to actually get the answer for this question here. And next, what column that we are joining for these two tables is going to be this character ID here. So using these two tables and their relationship, we should be able to come up with a final answer here. So the final answer is going to be select count item name. So we will be counting the item name from this character underscore item table here. Therefore, the next line is going to be from character underscore item. And next, we have to do some joining. So inner join character table here. And then next will be on character dot character ID is equal to character underscore item dot character ID. So we are joining these two tables based on this character ID column here. And finally, we have to do the filtering of cat123 here. So where character dot username is equal to cat123 and then the semicolon here. So this is how you can get 3 marks for this question here. Next, the following changes need to be made to the character with the ID 002. Level change to 3, money change to 10,000. Write an SQL script to change the character's data. So we have ID, level, money. So ID, level, money. So we will be updating this character table here. So this is the typical DML question here. So first of all, update character. And next, set level equal to 3, money is equal to 10,000 here. And finally, we do the filtering where character ID is equal to 0002. When it comes to database question, my students often find it challenging. But once you do some visualization like how I show you throughout this question here, you should be able to come up with the correct solution. A company has multiple sites in different cities. The company has drivers who deliver products to customers. Each driver can connect to the company's WAN wide area network whilst out of the office using a smartphone. State two ways that a WAN is different to a LAN local area network. So this is a typical WAN versus LAN question here. You can always remember that WAN is bigger than LAN here. So first of all, in a WAN, devices can connect over a larger geographical area. In a LAN, devices connect over a smaller geographical area. So this is the first difference here. And the second difference we can write, the transmission media for WAN is external owned. The transmission media for LAN is usually company owned, which means for the smaller network, we normally own the transmission media here. For B, the smartphones use the cell phone network to connect to the WAN. Explain how data is transmitted using the cell phone network. For this definition of cell phone network, normally I will tell my student to remember this diagram here. Based on this diagram here, we can easily come out 2 to 3 points based on the diagram itself here. So first of all, LAN is split into cells designed for maximum line of sight. So you can look at all these cells here. And next, each cell has a tower with an antenna which receives and transmit data. So we have all these tower here. And then data is transmitted between the tower and the phone since it's a cell phone network. And finally, we can write data transmission is wireless using lower power radio frequency here. So as I mentioned just now, if you can remember this diagram here, this is actually a relatively straightforward question. For C, devices that connect to the WAN have an IP address. Complete the following description of IP addresses by writing the missing words. First of all, IPv4 is displayed as 4 groups of 8-bit numbers separated by full stops here. And then each IPv4 address is 32 bits. IPv6 on the other hand is made of 8 groups of 4 hexadecimal numbers separated by columns. So this is the typical difference between IPv4 and IPv6. And then multiple consecutive groups of what can be replaced with a double colon. So this will be zeros here. And then each IPv6 address is how many bits? It's gonna be 128 bits here. And then next will be a something IP address can change each time the computer connects to a network. So the keyword for this statement here is gonna be change here, which is gonna be a dynamic IP here. And next, a something IP address can only be accessed by other devices in the same LAN and is assigned by the router within the LAN. So what is the keyword for this statement here? It's gonna be can only be accessed and then same LAN here. When we look at same LAN, we know that this is going to be a private IP address here. For D, the main office for the company has 4 wired computers, 1 server, 2 printers, 1 central switch, and a device providing a single point of access for the internet. The network is set up as a star topology. Draw the topology for the main office network, label all devices. For this type of question, normally I will just highlight all the components required first. So first of all, we have 4 wired computers, 1 server, 2 printers, 1 central switch, and a device providing the internet. And the network being used is going to be a star topology here. And now let's start drawing the diagram here. We'll start from the central piece here. So what is going to be at the center here? So for this question here, it's going to be this one central switch here. So a switch here. And then let me just cross out this switch here so that we can keep track of what we have drawn on this diagram here. And next, 4 wire computers. So computer 1, computer 2, computer 3, computer 4. So we have drawn 4 wire computer here. So let me just cross out these 4 wire computers here. And then 1 server here. So cross out the server here. And then printer 1, printer 2. So let me just cross out these printers here. And finally, a device for single point of access for the internet. So this one we can just draw router here. So nothing special about this question here. We just have to draw based on the question requirement and know that we are using router for access to internet. And finally for E, describe the role of a switch in a network. So let me just copy the diagram we drew on the previous slide first. So this is going to be this diagram here. So what is the role of this switch here? So this is a 3 points question here. So we can write to provide a central point of connection for the network. Pretty straightforward. If you look at this diagram, we should be able to come up with this statement here. And next, to store the MAC addresses of devices connected to it. So this is the typical function of a switch here. And then to get the last point, we can write to receive packets from devices here. So this switch will always receive packets from different devices here. And finally, to close it off, we can also write to forward packets directly to the intended recipients here. So this switch, it will receive packets and also forward packets to the right recipient. The following table shows part of the instruction set for a processor. The processor has 1 register, the accumulator ACC. So these are the instructions with their explanation here. And then the current contents of memory are all these address with their instruction here. Trace a program currently in memory using the following trace table. So we have the address, which is all this address here, the ACC content, and then we have the starting value based on this memory address here. So let's start with the first instruction here, which is this address 100 here. So 100. And then LDD 10. So what does LDD stand for? LDD address will load the content in address 10 into ACC. So what is in address 10? It's going to be 12 here. So 12 will be in this ACC here. And next will be 101 here. Add 12 here. So when we look at add 12, basically means that we will add the content in address 12 to ACC here. So 12 plus 10 is equal to 22 here. And then 102 here, STO 11 here, meaning that we will store this ACC value into address 11 here. So 22 will go into this 22 here. And next will be 103 is going to be CMP 14 here. So 103, and right now we are doing a comparison. So CMP 14 here. So what is in 14 is going to be 22 here. So 22 in ACC compared with the value stored in address 14 here. So 22 compared with 22 is going to be true here. And now let's look at 104 first. 104 is going to be JPE 107. So what is JPE? Following a compare instruction, jump to address if the compare was true. So the compare was true, we'll jump to 107 here. And finally, for this 107 here, we have STO 10 here, meaning that I will store the ACC value into address 10 here. So 22 here will be stored into address 10 here. And finally, we have 108 here, which is N here. We can just skip this statement here. So this is how we can get 3 marks for this tracing question here. And next, state the effect of changing instruction LDD 10 in address 100 to LDM hash 10. So basically this hash 10 is just a number here. So we can just write the number 10 will be loaded into the ACC due to this hash 10 here instead of content of address 10 here. So basically you can just get an answer, from this explanation here. So immediate addressing, load the number N to ACC. Direct addressing, this is the address, which is the value stored in this address here. And finally, identify and describe one mode of addressing not given in the table instructions in part A. So for this part A here, we have direct addressing, immediate addressing. So we have some other addressing here. So for this example here, I will just write indirect addressing. So what is indirect addressing? It's going to be the operand points to the memory location that contains the address of the data. If you look at this statement here, it might sound a bit confusing to you, but no worries. Let me just show you a very basic example here. For example, let me just show you LDI 12 here. So this is indirect addressing mode. So what does LDI 12 do? Let's look at address 12 first. So in address 12, we have the value of 10 here. So instead of loading this value 10 into ACC here, we will jump into address 10 here, which is this address here. So what happened here is that we will take this value 12 instead. We'll take this value 12 and then load this into ACC, resulting in ACC having the value of 12 here. So this is indirect addressing mode. In a simple way, you can just imagine that it's actually pointing to the address of the address, if that makes sense to you. For B, the table shows part of the instructions set for a processor. The processor has one register, the accumulator ACC. So these are the instructions here. And you just have to take note of this one here. Hash denotes a binary number, so hash 123. B denotes a binary number, e.g. B01001010, and denotes a hexadecimal number, M4A here. The ACC currently contains the following binary value, 11110000. Write the result after the instruction OR B00001111 is run. So this B stands for binary number here. So for this kind of question, normally I will just move this to the top here, resulting in this 00001111 on the top here. And then now let's just do basic operation. 101, 101, 101, 101, 011, 011, 011, 011. So this is quite an easy question here. And next, the ACC currently contains the following binary value, 00011101. Write the result after the instruction SOR hash 30 is run. So hash stands for binary number here, meaning that we have to convert this 30 into binary number here. So how do you do the conversion? It's pretty easy here. First of all, as usual, I will just write 1, 2, 4, 8, 16, 32, 64, 1 to 8 here. And then let's look at how we can compute 30 using this number here. So 30 is equal to 16 plus 8 plus 4 plus 2, resulting in 00011110. And then I will just move this number to the top here. So 00011110. And then just do a SOR operation. So 011, 101, 110, 110, 110, 0000000. As you do this walkthrough together with me, you will realize that you still need to close some gaps and improve your understanding on certain topics to get the best possible grade for your upcoming paper 1 exam. So, if you are running out of time or don't really want to waste your effort on the wrong resources, check out my fast track program at www.haguin.school. I have helped students from more than 30 countries to hit their target grade and secure offers from their dream universities. So do check out the program if you are serious about your grade and your university. Lastly, I wish you all the best for your revision. Thank you, and I will see you again then. Bye bye.